Now, let us focus on the differentiation of inverse hyperbolic functions. So this is the differentiation formula for inverse hyperbolic functions. As I mentioned earlier, the inverse sine hyperbolic u is not means like this. This is the wrong concept. Okay, so you cannot simply differentiate the inverse like this because -1 here does not mean as exponential, but it means the inverse of the sine hyperbolic. So the differentiation of sine hyperbolic is given as 1 over square root of u square plus 1 and times with derivative of u over dx. And the rest of the inverse hyperbolic functions are listed here. Okay, now let us proceed with the example. There are two questions here. The first one is to find the derivatives of the following functions with respect to x, given the function is a and b. And the second question is given y is equals to the inverse cos hyperbolic x square. You have to show that x square minus 1 multiplied with dy over dx square is equals to 4y. You can pause this video and try this out, and then after that you can continue to play this video to show or to see the solution for this question. Now let us try solve question number 1a. So y, as you can see here, it is a product of two functions. The first one is 1 minus x, and the second one is inverse tangent hyperbolic 3x. So the first one, we can assume it as u, and the second function, we assume it as v. So since this is the product of two functions, we will use the product rule in order to find the differentiation of this equation. So first, we know that d over dx of a product rule is equals to u times with derivative of v plus v times with the derivative of u. We have here u is equals to 1 minus x, and du over dx will be -1, and v is equals to the inverse of tangent hyperbolic of 3x. Therefore dv over dx is equals to, so first we have to differentiate the outside function, which is inverse tangent hyperbolic. So the derivative of inverse tangent hyperbolic is 1 over 1 minus, so this will be remain the inside, which is 3x square times with the derivative of the inside function, which is 3x. So this will be 1 over 1 minus 9x squared times with the derivative of 3x, which is 3. So this will be 3. So now we have the derivative of u and the derivative of v. Now we can solve dy over dx. where dy over dx will be this, where u is equals to 1 minus x times with v prime, which is 3 over 1 minus 9x squared, plus v, which is the inverse of tangent hyperbolic 3x, times with u prime, which is -1. So we simplify this, we get 3 times 1 minus x over 1 minus 9x squared minus the inverse of tangent hyperbolic 3x. So this is the derivative of question number 1a. Now we proceed with question 1b to find the derivative of inverse cos hyperbolic of secant x. So dy over dx is the so we find the derivative of inverse cos hyperbolic. So we get 1 over u square, which is u is represented as secant x, minus 1 times with the derivative of the inner function, which is secant x. So next we rewrite this, where this will be secant square x minus 1 times with the derivative of secant x, which is secant x tangent x. We can simplify this equation, where using the identities, we know that 1 plus tangent square x is actually equals to secant square x. So tangent square x is equals to secant square x minus 1. So we can represent this secant square x minus 1 as tangent square x times with secant x tangent x. So the square root of tangent square x will be 1 over tangent x times with secant x tangent x. So this will be 1. So the final answer is secant x. So the derivative of this equation will be secant of x. The last question, if y equals to inverse cos hyperbolic of x squared, we have to show that x squared minus 1 times with dy over dx squared is equals to 4y. So what we need to do is we have to find the dy dx of this, and then we substitute into this equation, and then we must make sure that the final answer will be equals to 4y. Okay, now the first thing is you have to find the dy dx of this, where this is the power of 2. So we can differentiate the outer function. So this will be 2, and the inner function will be remains, which is cos hyperbolic inverse of x times to the power of 2 minus 1, which will be 1, times with the derivative of the inside function, which is cos hyperbolic inverse of x. So we rewrite this. And then from the formula given, the derivative of inverse cos hyperbolic of x is equals to 1 over x squared minus 1. So we simplify this. So we get 2 cos hyperbolic inverse of x over x squared minus 1. Okay, now what we need to do is we substitute into, we want to show that this equation is equals to 4y. So we rewrite the equation x squared minus 1 times with dy over dx squared, where this is equals to x squared minus 1 times with dy over dx is 2 cos hyperbolic inverse of x over square root of x squared minus 1 square. Okay, then we have x squared minus 1. So all this will be square. So we have 4 times with inverse cos hyperbolic of x squared over, the denominator also will be square. So at square root of x squared minus 1 square will be x squared minus 1. So x squared minus 1 divided by x squared minus 1 will be 1. And then we get equals to 4 times with inverse cos hyperbolic of x squared, where this inverse cos hyperbolic x squared is actually equals to y. So this is equals to 4y. So it is shown that x squared minus 1 times with dy over dx squared is equals to 4y.